This video is over lesson 109, Graphing Systems of Linear Inequalities, and it is for my Algebra 1 class. A system of linear inequalities is like a system of equations. It's just a set of linear inequalities with the same variables. So a solution, just like the solution to an equation, the solution to a system of equations, the solution to a system of linear inequalities is just the values of the variables that make the inequalities true. In this case, though, we're going to have an ordered pair. There's going to be an x value and a y value. And so they have to make all of the inequalities in the system true. But other than that, it's the same exact idea as what we've been doing. So, ladies and gentlemen, we are going to take a look at the practice problems. So if you'd write practice in your notes, please. And then this is on page 738. 738. And we'll start with letter A. I'm going to start by just copying the problem down. And often we write a system using a brace in the front just to say these are two things that I'm starting with. So that's what I'm going to do. Y is greater than negative 2x minus 1. And then y is less than or equal to 1/5 x plus 4. And we're going to go ahead and graph these. So remember the key to graphing and linear inequality is we treat the less than, greater than, less than or equal to, greater than or equal to as if it was an equal sign, and that is our boundary line. So if you pretend it was an equation, that would be your boundary line. Now, if it does have the option of being or equal to, then that means that the line itself is included in our solutions. And so therefore it's a solid line. On the other hand, if it's not included, so it's just a greater than or a less than, that means that the boundary is not included, therefore it's a dashed line. So for my first one up here, I'm going to have a dashed line. But this is basically y equals mx plus b. This is slope-intercept form here. So that's convenient for me. Let's go 6 in every direction. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. All right, so that's my coordinate plane. I think I missed one there. One more. That's the trouble of looking back and forth between a screen and a piece of paper. Sometimes you lose track of what you're counting. Oh goodness, I lost track all over the place, didn't I? Oh well, whatever. Yeah, I think you guys got the idea there. All right. So first one, if we're thinking about this as y equals mx plus b, we're going to use our b here to start with. That's going to be my intercept at negative 1. And the slope of negative 2 means that I'm going to either go down 2 and right 1, or up 2 and left 1. So down 2, right 1, down 2, right 1, up 2, left 1, up 2, left 1, up 2, left 1. And then since this does not have the or equal to, remember this will be a dashed line through these points. Still have an arrowhead on each side. And now I want to figure out which side are the solutions to this on. So that's the boundary. And so we choose a test point, a point that's not on the boundary, plug those values in, see if it makes it true. If it does, then the solutions are on that side. If it doesn't, then the solutions are on the other side. Remember, the origin is often a nice test point. So my boundary does not go through the origin, which means I can use that. So I plug in 0 here, and I plug in 0 here. Well, that will turn that into 0. And then minus 1 would be a negative 1. So is 0 greater than a negative 1? Yes, it is, which means the solution to this are on this side. Now, what I'm going to do is I'm just going to put a couple little marks here. Normally, we would shade that in big time, but I'm not going to just yet this time. I'm going to hold that for just a moment. Now I'm going to graph the other one, because remember, this needs to be all the points that make both of them true. So I need to know where the other one is. So for the other one, if we imagine y equals mx plus b, then my intercept is up here at 4, and my slope is 1/5, so it tells me to go up 1 and right 5. So up 1, 1, 2, 3, 4, 5. Or I can go down 1 and left 5. 1, 2, 3, 4, 5. And since it does say or equal to, that means that this one actually is a solid line. And now if we choose a test point, let's choose 0 here. So 0 and 0, so that'll just be 0. 1/5 of 0 is 0, plus 4 is 4. So 0 less than or equal to 4? Yes, it is. So that means the solutions to this are on this side. Now, in order to be a solution to the system, it has to be a point that makes both of these true, which means that our solution is going to be this space where the two of them overlap. It'll be the overlap of the two. And that's how we graph a system of linear inequalities. So let's try B. If I move on to B now, I'm going to copy my system first. 6y plus 6 is greater than a negative 2x. And then I have a y is less than 2. So as I look at the first one, I don't really like how that one's laid out. I would prefer that to either be in standard form or in slope-intercept form. So I'm going to do a little bit of algebra here, and I'm going to take my 6y plus 6 is greater than a negative 2x, and then I'm going to add 2x to both sides. And so, no, let's go slope-intercept. I was going to do standard, but let's do slope-intercept. That one's more comfortable usually. Changed my mind. So it's minus 6. So 6y is greater than a negative 2x minus 6. And then divide both sides by 6. Therefore, y is greater than, and this will distribute, remember. So it'll be a 1/3 x minus 1. 1/3 x minus 1. So I don't need quite as much space as I needed last time. So let's come down here. Let's see. Can we come down 5? Do I have room for 5? It looks like I just have enough room. So 5 in every direction. So there's my coordinate plane there. So I have an intercept at negative 1, and then a slope of negative 1/3. So down 1, right 3, up 1, left 3. This says just greater than, which means therefore this will be a dashed line. So choose a test point to see what side the solutions are on. 0, 0 is nice. So if I plug in 0 here, that'll just be 0. Minus 1 would be a negative 1. So 0 greater than a negative 1? Yes, it is. So again, my solutions are out here to that one. Now here, again, remember this, treat this like it was an equation. So if this is y equals 2, remember that y equals a number produces a horizontal line. So my boundary here will be horizontal going through 2. And since it just says less than, that means that it will be a dashed line going through it too. Now if we consider the origin, Well, we don't have a y value to plug in, so is 0 less than 2? Yes, it is. So what I might want to do here is I might want to come up and see, can I get this a little closer? And kind of see where these almost cross there. And so our solution to that one is going down towards the origin. So then it's going to be this in-between space right there. And that is the solution to my system. Any point in there will make that system true. If we move on to C, it tells us to graph using a graphing calculator. We're actually going to do that one by hand. And then we'll do it with the calculator. So for C, I have y is greater than or equal to x minus 6. And then I have y is less than or equal to a negative x plus 3. And so those are all set with slope-intercept form. Let's try 6 in every direction again. Maybe I can count a little better this time. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. All right, so there's my coordinate plane. Again, treat these like they were equations for the sake of graphing your boundary. They both have or equal to, which means both of these will be solid lines. So if I started at negative 6 with a slope of 1, so up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So I'm going to have a solid line going right there. Now is the origin a solution? So if this would be 0, minus 6 would be a negative 6. Is 0 greater than or equal to a negative 6? Oh, yes it is. So the solutions are going to be on that side. And then finally we do this one, so we have an intercept of 3. And then a slope of negative 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Up 1, left 1, up 1, left 1, up 1, left 1. That's good. Again, since it says or equal to, that's why it's a solid line. Now if we test the origin, so 0, negative 0 would just be 0, plus 3 would be 3. Is 0 less than or equal to 3? Yes, it is. So my solutions are down towards the origin. And so we can see hopefully clearly where they overlap. They overlap right here. So if you kind of imagine a square around your coordinate plane there, my shading, notice, goes to kind of the ends of that square. All right. And moving, oh, sorry, we were going to do that on our calculators now. So if we look at our calculators and we plug in the first one as if it was an equation, so we have x minus 6. So then if you graph that out, when we test the origin, we want it to go up. So now if we come back over here to y, we want that to go up. So we change that to up. And then for my other equation, I have a negative x plus 3. So if we graph that, maybe it's a little hard to see. So one of the things you can do, so I come back to my y value, I can turn off this one by going and highlighting the equal sign and hitting enter. And so it's still in the calculator, it's just turned off for graphing for this moment. So now I can see, okay, that doesn't go through the origin, so I try the origin, test it out, find out it needs to go below. So now if I come back over here to y equals, I can come down here and turn this one into below, and then I can go back to y sub 1 and turn him back on, and then if I hit graph, and you can see where they overlap. And where they overlap, that's where a solution is. So compare that to my graph, pretty similar. All right. For D, E, and F, I'm going to come to the back. I'd like to keep those three together. There's kind of a purpose in that. You'll notice some similarities between them. So D, I have y is greater than 1/2 x minus 4, and then y is greater than 1/2. So this time, for the sake of space, let's just go 4 in every direction. So my first one has a y-intercept of -4, a slope of 1/2, so up 1, right 2, up 1, right 2. Since it does not have the or equal to, it's just a dashed line. Plug in a test point, the origin works nicely, so if that's 0, -4 would be a -4, so 0 greater than -4? Yes, it is. So the solutions will be on that side of it. And then for the next one, it does not have a plus or minus anything, which means the intercept is actually at the origin. Same slope though, so up 1, right 2, up 1, right 2. I can go down 1, left 2, down 1, left 2, and so dashed line. Since the origin is right here. Oh, I forgot my X there. Since the origin is on the boundary, that means that I cannot use it as a test point. I need to choose a point on one side or the other. So maybe I plug in 1, 1. So let's see if 1, 1 works. So if I plug in 1 for y and 1 for x, 1/2 of 1 is 1/2. So is 1 greater than 1/2? Yes, it is. So the solutions are on this side of the line. So notice we have two parallel lines. And so because I have two parallel lines, that means that there are a few different possibilities. One of them is what we're going to see right here, that it's only the overlap that are solutions. So it turns out that nothing over here is going to be a solution. So all of it is right up here. So we actually didn't even need the first inequality, because the answer just ends up being the second inequality. Move on to E. So for E, y is less than 1/2 x minus 4, and y is greater than 1/2 x. So again, we're going to have those parallel lines. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. 2, 3, 4. Okay, so same boundaries. This time, though, I went from a greater than to a less than. So if greater than was up top, less than must be down here. However, this one, if I graph that quickly, because we just did it a moment ago, still has solutions up here. So what we see is parallel lines can result in no overlap. And so when something like that happens, we'd have to say that there is no solution. So letter E has no solution. And finally, letter F. So my system says y is greater than a 1/2 x minus 4, and then a y is less than a 1/2 x. So same deal, 4 in every direction. So intercept of -4, slope of 1/2, up 1, right 2. And so since it's a greater than, plug in 0, that'd be 0, that'd be -4 then. So 0 greater than -4? Yes, all the solutions are back up there again. And then down here, no intercept, which means it goes through the origin. And still a slope of up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. And then no or equal to's, so it's still a dashed line. So this time if I plug in 1, 1, I'm going to get 1/2 times 1, which will be 1/2, minus 4 would be a -3.5. And then 1 up there oops, sorry, I'm plugging in for the wrong thing, aren't I? Sorry, 1, 1. I knew something was funny there. Yeah, second inequality. Sorry, plug in 1, 1. So if I plug in 1 and 1 here, so 1/2 of 1 is 1/2, and this is 1. So is 1 less than 1/2? Well, no, it's not. So if 1, 1 is on this side, the solutions then would be on the other side, and we can see the overlap here between the two parallel lines. That's F. Last one is G. G. Brett has $30 with which to buy dried strawberries and dried pineapple for a hiking trip. The dried strawberries cost $3 per pound, and the dried pineapple costs $2 per pound. Now, time out right there. So how much is Brett spending in strawberries? Hopefully you just said 3x. So if it's $3 per pound, we don't know how many pounds, so make that x, 3x. How much is Brett spending on dried pineapple? Well, I hope you said 2y. So if it's $2 per pound and we don't know how many pounds it is, well, let's use the variable y. And so we know that he has $30 with which to buy these. Well, I'm sure he'd be perfectly fine with not spending all 30, but if necessary, he could spend all 30. So that means if I add these two amounts together, that this must be less than or equal to 30. All right, let's keep reading. Brett has at least 2 pounds of strawberries, or needs at least 2 pounds of strawberries. So strawberries was my x. So x has to be at least. At least means it could be greater or equal to the 2 pounds that he needs. And then finally, Brett needs at least 3.5 pounds of pineapple. So therefore, y must be at least 3.5. So this system actually includes 3 different things. So when I make my graph, I need to take into account all 3 of them. Now, these two are just going to be, this is going to be a horizontal line, that'll be a vertical line. Up here, if we think about that in standard form, Remember, standard form is nice for intercepts. So if I plug in 0 for y, so 3x equals 30, therefore x would be 10. So 10 comma 0 is my x-intercept. I plug in 0 for x, so 2y equals 30. Divide both sides by 2, y equals 15. That would be my y-intercept. So I kind of like that. So 10 and 15, though, are two values that are going to come up. So I got to decide how big do I want to make this. Let's go. Let's go 6 in every direction. All right, so first one, remember we said we had an x-intercept at 10. So what I'm going to do is I'm going to call this 2, 4, 6. And call that 2, 4, 6. And so we know we're counting by 2's. So 2, 4, 6, 8, 10. And then if we solve for y, that'll give me my y-intercept. So 2y equals 30. Therefore, y equals 15. So 2, 4, 6, 8, 10, 12. I didn't quite make this big enough. So 15, that was 12, 14. 15 would be way up here. So plan ahead a little better than I just did there, ladies and gentlemen. And it says or equal to, so that means it's going to be a solid line between those two. And so if we plug in 0, 0, so 0 and 0, we make all that 0. So 0 less than or equal to 30? Yes. So solutions would be going that way. You'll notice I didn't put arrowheads on this because actually, since we're dealing with real world numbers, these numbers can't be negative. You can't have a negative amount of dried strawberry. You can't have a negative amount of dried pineapple. So now the next one is going to be a vertical line through 2. So vertical line through 2, and it's a solid line again. And so if I plug in 0 there, is 0 greater than or equal to 2? No. And then finally, y is greater than or equal to 3.5. So 3.5 would that'd be 3, so that'd be 3.5. It's going to be horizontal line. And so then we plug in the origin for that. Plug in 0 for y. Is 0 greater than or equal to 3.5? No. So the solutions have to be going up this way. So, well, where do they overlap? They overlap in this triangle right here. That, ladies and gentlemen, is the end of our video.